Okay, this is the second class in the Echinodermata, the phylum Echinodermata that we're going to be looking at. This is Ophiuroidea. This is video 3 in the Echinodermata series. And these ones are brittle stars and basket stars. So let's have a little slideshow of what sort of organisms we're going to be looking at. Here's a beautiful tropical reef one you can see, because here we have a theca, right? That's the calcium carbonate shell of the Cnidarian coral. And we don't have reef building tropical corals here like there are in the tropics, so we know that's a tropical picture. Here is a basket star, okay, and another image of a basket star. There's another image of a basket star all curled up. Alright, so you'll see lots of these in the tropics. Here's one feeding on a Gorgonian sea fan, or not feeding on it, sorry, sitting on a Gorgonian sea fan. Here's one all wrapped up. That's what they do when they're not feeding. Another one wrapped up, not feeding. Here you go, test yourself what phyla are represented. And let's see, if we look at some of the local ones, we've got the Ord sand star, and here we have a mottled brittle star, and here's a local snake star. Okay, so snake star. So these are all the brittle stars, and what you'll notice about them, if you look closely, you can find all three of these at Pilot Bay. Again, the wonderful dive site that is the Maori Warrior. You'll see these ones, but you'll notice that all of them have this central disc, okay, and then the arms, which look almost separate, like they're not joined. Here's a central disc, and then these arms that are almost detached from the central disc. The arms, they don't have ambulacral grooves. If we're looking at the general characteristics of Ophiuroidea, there are no ambulacral grooves. And if you remember what ambulacral grooves were, that's where the tube feet came out. They do have a water vascular system, just like all the echinoderms. They have tube feet, but mostly used for feeding, not for movement, and they have no suckers on the end of them. So they're not really for gripping things so much as moving food along the length of the arm. And no anus. So these these are different than the rest of the echinoderms that we're going to be looking at, because they have a two-way gut rather than a one-way gut. So they don't have a mouth and a separate mouth and anus. They have just one entrance, which is the mouth and the anus. Okay. Some of the locals again. Okay. The arms are divided into segmented sections, and these ones are called brittle stars because these sections will break quite easily. Alright, the arms can break off quite easily, but they have the ability to grow those arm segments back quite well as well. And they have, rather than, as we've said before, they using the tube feet to move, they have long muscles that go down the length of the arm and help them move by large muscular movements. And we'll look at that a little more in class, and also through a couple of YouTube videos of brittle stars moving. And each section of the brittle star arm, so we'll look at that a little more closely, has 4 ossicles, and they're called shields, and 1 pair of podia. So you get what essentially is a segmented arm, and each of the section has 4 ossicles and 1 pair of podia. So you get a repetition of segments down the arm, and this is why it can be easily grown back if a fish bites one of these arms off or they happen to lose one somehow. So here's the oral side, the oral side of the brittle star, and you can see the central disc here, and then the arms, which are all sort of joined here in the middle, and then you have these big shields here, okay, oral shields, and a 5-sided star that leads to the mouth. And here we go. We've got the pentamerous radial symmetry again. All right, the 5 slices of a pie, but the 5 radiating out lines of symmetry. And here you can see the segments, the segmented arm, where this is joined. This has lots and lots of repetitive sections. Okay, so we'll look a little bit closer at the structure of the arm. And if you look at these segments, you can see that there are a whole lot of little panels lined up along the bottom of the arm, and then a whole lot of panels along the side of the arm and on both sides, and then we can't see the top, but there's another set of panels along the top. And each of the sections would be divided up so that it have one of these bottom panels, 2 of the side panels, and 1 on top. These are called the oral shields, the lateral shields, and the aboral shield, or the top shield. Okay. And then, if we look very closely at this underside of the arm, we can see the 2 feet sticking out as well. And again, you'll notice that they're just little stumpy piles with absolutely no sucker on the end. It's just a rounded tip on the end. Okay, so they've come out these little holes that are between the oral shield and the lateral shield. So if we look at the outline of this, you go around here. This is the outline you can see of the this ossicle, or this lateral shield, lateral being on the side, and the lateral shields generally have spines. Okay, so if we go here to another view of it, okay, we've got the oral shield. This is one section, one of those repetitive sections of the arm, and we have the oral shield, which is that plate along the bottom, and that's an ossicle. Here is the lateral shield on one side and the lateral shield on the other. And these shields, these ossicles, have spines that come off of them. So often with a brittle star, you'll see the spines. And then you have a top shield called the aboral arm shield, and that's another ossicle. So this is the cross section. 1, 2, 3, 4 different ossicles. And the spines that come off to the side are used to give it a lot of grip. Okay, so you'll see that these things, when you see one walking along, it can dig these into the substrate and move itself along. It's got a lot of purchase with these arm shields. And obviously, if we look at, say, this one compared to this one, the spines on the lateral shields can be greatly different in size depending on the species. Or say this one here, very much reduced lateral spines and very elongated, bigger lateral spines. Okay, so they've got the 2 feet still coming down, so this is the radial canal, and then the lateral canal coming down to the 2 feet. But the 2 feet work very, very similar, in a similar manner. They, again, are controlled by the water vascular system and can extend, elongate, move. They've got muscular control, but they don't have suckers at the end. And in class we'll look at how these things pass their food down the length of the arm. And essentially that's what these 2 feet do. these things will pick up organic particles and just pass them by gripping between the two of these and moving that organic particle down the arm to the mouth, to the central disc. Okay, so then it's got 4 long muscles that will run the length of the entire arm, and those give it a bit of power when it's moving. And so if you go to this URL and or if you just type in brittle star movement onto YouTube, I think you'll come to this video very quickly, and just have a look at how brittle stars move, and it should help you understand how those arms work. Alright, podia reduced and extend between the oral and lateral shields. Okay, the madreporite located on one of the oral shields. So the madreporite will be in the center, and instead of like the asteroidians, where the madreporite was on the top, this one is located on the oral side, on the bottom side facing down, and it still works the same as the madreporite in an asteroidian. It's joined by the stone canal to the ring canal and allows water to move into the water vascular system. Okay, so how do these things live? They might be carnivores, they might be scavengers, okay? They might be deposit feeders, or they could be filter feeders like we saw with the basket stars. So the basket stars have mucus slung between the spines, and whatever plankton comes along and sticks to that, or any organic materials that stick to that, will get passed down to the mouth and then ingested that way. Often, what you'll find with the ones that are deposit feeders or or the carnivores or scavengers, they will, when you're diving along and you want to find brittle stars, you often look underneath rocks, or you'll see their arms sticking out from underneath rocks. And that is because what they can do is they can sit underneath the rock and just have their arms coming out, sweeping the surface, looking for whatever organic material has fallen down, and then picking up that organic material and bringing it to their mouth. And they can keep the central disc, the middle part, underneath the rock for protection at all times. So only the center of only the tips of the arms are exposed. Okay, so they can stay within their protective retreat. All right, and then they've got, if you look at the bottom side of the Ophiuroid, the brittle star, they've got 5 jaws, these plates that come together and can crush up food, macerate it, essentially chew it. These things can widen out and come together and chew, so that they can crush up the food prior to going into the stomach. Okay, and here is a picture. You can freeze on this, and it's a picture of a bolus of food being moved down the arm by the 2 feet. Alright, gas exchange. These things have bursa, which are, let's have a look here. Bursa are in the central disc, and they are folded in lots of folds, which increases surface area, and they have cilia lining them, and the cilia beat, which creates a current, moves the water in and out of this cavity, and that's where gas exchange can occur, and also through the tube feet in the on the arms. Okay. Okay, so that is another cilia coated surface and so we see a lot of the same structure in lots of different animals, and genetically we use a lot of the same structures and the same proteins and things like that to help build our bodies, and but just modified for different purposes. And so that is another link to why evolutionarily lots of organisms, or pretty much all organisms, are connected. If something is used well or has worked well for one organism, it may work well for another. Okay, but through modification. Okay, so here we go. What phylum do we have here? See if you can test yourself. Okay, reproduction is both sexual and asexual. Alright, they may broadcast spawn, and they are usually dioecious, but maybe hermaphrodites. Okay, or they may sex switch. They may start as males and then move to females. Okay. That is about everything that you need to know for Ophiuroids, and our next class will be Echinoidea in Echinoderms 4.